Hello, we are the team number one with the topic of quality of service, the part number one. What is quality of service? It's the collective effect of the performance of a service that determines the degree of satisfaction of the user of that service. And could be another meaning, the ability of satisfy the customer result in quality of service. What is? It could be in two options. Elastic is attached in case in a big changes in delay and throughput. Also maintains the functionality of the application. In Elastic, inequality requirements aren't met, the utility becomes zero. The first parameter is bandwidth. It's a certain amount of data that is transmitted in a certain time. It's achieved by means of packet header identifiers and it's used to give priority to the traffic of a certain type of file. For example, video, sound, and voice. Delays. The packets may take a long time to reach their destination due to longest queue or take less direct routes to prevent network congestion. The next parameter is the jitter. It's an unwanted and abrupt change of ownership of the signal. Variation in the time of arrival of the packets caused by network congestion, loss of synchronization or via different routes followed by the package to reach their destination. And the last one is the packet loss. Misdirect the package combined with each other or corrupted when route. The receiver has to detect them and just when the package is realized, it asks the transmitter to repeat it. The solutions to improve QoS in data networks. The first one is the bandwidth control and optimization. Allows the maximum performance and value of application and technologies, monitors, compresses, and control links bandwidth. Use the align one resource with tools of the QoS managed network. Network monitoring. They allows a clear and comprehensive view of overall network activities with monitoring, alerts, and understanding of unusual events in real time to make forecasts and avoid potential network congestion. Link optimization acceleration enables highly efficient data understanding and static and dynamic content storage in cache to accelerate application response time. Protocol Analyzer. It allows network analysis and auditing using different interfaces for the different user segments, offering a clear and simple console that displays the information of the user needs. And this is a case of QoS. The Air1 router has been configured to allocate up to 5 megabytes of the 10 megabytes available for video transmission. FTP traffic is allowed to use 2 megabytes and HTTP and all other traffic can use a maximum of 3 megabytes.
QoS models. The two QoS models architectures used in IP networks when designing a QoS solution are the inter-serve and leaf-serve models. There are three types of models that we are discussing in this video and in this presentation, which will be presented in the next slides. The first of these models is best effort service, the standard form of connectivity without any warranties. This type of service, in reference to catalyst switches, uses first in and first out queues, which simply transmit packets as they arrive in a queue with no preferential treatment. What this model means is that no QoS policy is implemented It is natural to wonder why this model was not called no effort. Within this model, packets belonging to voice calls, emails, file transfer, etc. And the easy way to see this model or to explain this is that this model is the easiest of the three models. This model does not have a special treatment to the packets or different categories of the packets because it just sent the packets as it received the packets. It is simple. That's why it is the easiest of the three models.
Hello everyone, my name is Cristian Gesayaguado Ramirez and I'm going to talk about int serve. What is int serve? Well, here we have information about it. This model is based on the idea of reserving resources in the network by float. A stream is a chain of packets following through the network from an application on a source computer to application on the target computer. For each incoming stream, the resources, branding, delayed, it, whatever else that will be needed for this stream are defined. A part important of this topic is resource. Resource reservation must be established in advance for each of the other routers that are part of the part between the source and derivations. Each node is the part indicated wherever it can source the reserve and maintains a table with the state of the reserve per flow. The main limitation of this model is the large amount of information that each node must store, making the solution not applicable in situations with large amount of flows between end source. We have the most important features are the number one, negotiate the specific service quality condition before the actual communication begins. The number two, once the reservation is made, the application has resources reserved beyond the network traffic situation. The number three, it can be adapted to specific and different demands of each type of traffic or application. The number four, the reservation of resources is made of each particular information flow. The number five, resources are not reserved according to the application generally. The number six, when associated with IP telephony development, it gives a connection-oriented approach to this type of service. The number seven is device along the router. The route configures and maintains the operation of each common communication individually. The number eight, and the last one, it is not scalable in large network or very complex implementation. And the last one, well, it uses RSVP, Resource Reservation Protocol Service, DIV service. It consists of a method of making of labeling packages, following the routers to modify their sending behavior. Each type of label represents a central type of QoS, and traffic with the same label is treated in the same way. Each operation define the serve divides the traffic into a few classes, and resources are assigned based on the classes. And and not on individual flows like interserve, which makes this infrastructure free from the problems and network resource dependence. For traffic and control, DivServe has two routers, border node and inter nodes. Only border nodes classify traffic and make mark package, while interior nodes use the classes code in the package header, call forwarding equivalent classes to determine the treatment of packages. Let me change the position. Yeah. The key concept of DivServe can be summarized as follows. There are five, and we start with the first one. Take advantage of the scalable properties of classes-based cost tools to define it between package types with the goals of differentiating services of the internet. The second one, in the simple network, the package should be marked and at the entry to the point within the network with other devices making cost choice based on the market fields. The, the next one, the market field will be in the IP header in not to in the data link layer header, since the IP header remains throughout the network. The number four, within network, packages can be reclassified, and remaked when entering another network. The last one, to facilitate making the IP header has been redefined to include a 6-bit field called DSCP, which allows for 64 different classification. Yeah, 64. Implementation model of resource oriented in a generic way are not by floors or sessions. Allow to warrant different services condition from different types of traffic in a scalable and effective way throughout the internet network. Let me change it. The number one, it doesn't require prior signal. It does not allow warranty and then traffic condition. The number three is a very flexible and scalable. The number four, and the last one, it divides traffic into the classes according to the requirements of the organization.
Hi, my name is Fernando Palomar, and I will talk about the description of DivServe QoS. Well, differential service is a QoS protocol proposed by IETF, RFC 2475 and RFC 2474 that allows to distinguish different classes of service by making the packet. It consists of a method for marking or labeling packets, allowing routers to modify their sending behavior. Also, DivServe divides the traffic into a few classes and resources, or allocator based on the classes. So this architecture doesn't suffer from the problem of network resource depletion. The key concepts of this chart can be summarized as follows. First is take advantage of the scalable properties of class-based and QoS tools for different between packet types with the goal of differentiating service of the internet. Other is in a simple network, packet should be mark the entry to a point within the network with other device making QoS a choice based on the market field. And finally is a market field will be in the IP here and now in the data link layer here, since the IP here remains throughout the network. This is all from the description of about deep server QoS, and finally this is all from use. Thank you for your attention.